Hello everybody, welcome to my lecture on partial differential equations. This is an introductory lecture and I will discuss in this lecture the basic idea of partial differential equations and some basic concepts. So let us begin. As you know, if in any physical phenomena, if the dependent variable depends only one independent variable, then it will result an ordinary differential equations. For example, consider the mass spring system. In this system, the spring is attached here and a mass is hanged in the lower end of the spring. When we pull this spring with the displacement of y and released freely, then there arises a motion. This motion is a periodic motion, which is SHM. In this system, there are two forces that are working, and the system is undamped system. That means there is no external hindrance and no external restrictions or no external forces. So only forces are upward forces and downward force. The upward force is due to the rigidity of or the elasticity of the spring, and it results the right hand side, and the downward force is due to the acceleration, and this is the left hand side force. So both forces are equal but in different direction. So we will have m d2y over dt square equals to minus ky. That means we will have an ordinary differential equation of second order. When the dependent variable depends upon more than two independent variables, then the partial differential equations may occur. Partial differential equations arise in various fields like geometry, physics, applied mathematics, life sciences, physical chemistry and engineering also. It has wide applications in almost every field of science. Let us define the partial differential equation. An equation is called partial differential equation if it has partial derivatives. You have already studied in the previous classes the partial derivatives, and that means if equation has partial derivatives and dependent variable and independent variable, then it is partial differential equation. So let us have look on some examples. So in the first example, z is the dependent variable and x and y are the independent variables. Similarly, in the second, u is the dependent variable and x, y, z are the independent variables, and del u over del x, del u over del y and del u over del z are the partial derivatives. And in the third one, u is the dependent variable and x and t are the independent variables. Now let us discuss some physical examples of PDE, partial differential equations. here PDE is used as an abbreviation of the partial differential equation. So the first example is heat equation. So what is the physical conditions of the generation of the heat equation? So we will have a rod that has the length capital L, and this rod has the constant density and the uniform cross section area, and the lateral surface, this lateral surface is insulated, so the flow is in the only one direction, and the rod is sufficiently thin so that the temperature is same at all points of any cross sectional area of the rod. If we assume that uxt be the temperature of the cross section at any point x and at any time t, this distance, suppose x, at any distance x and at any time t, uxt be the temperature, then this physical situation can be modeled as a partial differential equation, that is del 2u over del x square equals to a1 upon a square del u over del t. So here t is time and x is the position. So this is known as the heat equation. Now another example is wave equation. So what is the physical conditions and the assumptions of the problem is, suppose we have a string of length L that is stretched between two ends O and A, and if there is some distortion in the string, then the string will have a periodic motion. Again, suppose uxt be the deflection of the string at any point x and at any time t. That means at any point x and at any time t, this is the displacement, this y is the displacement, this should be y, this y is the displacement. Then this physical situation can be modeled, can be proved as a partial differential equation of second order, that is known as the wave equation. Here we have given these two physical situations as an example, but in second unit we will prove these equations, heat equation and wave equation. Now some basic concepts. As you have already studied in the ordinary differential equation, the order of the differential equation and degree of the differential equation. Analogously, we will define here the order of partial differential equation. The order of partial differential equation is defined as the order of highest partial derivative that occurs in the partial differential equation. So in the first example, the highest order derivative is of order 2, therefore order is 2, and in the second equation order is 1. Degree of the partial differential equation. The degree of the partial differential equation is the degree of the highest order partial derivative, provided that the partial differential equation is in rationalized form, that means free from radical signs. So in the first example, the partial differential equation has degree 1, and in the second one it is not in rationalized form. If we try to rationalize it, then on squaring both sides we will have del 2u or del x square whole square del u over del y plus 5u. Now it is in the rationalized form, and the degree is the degree of the highest order derivative, that is 2. Now we can classify the partial differential equation as linear and non-linear. This is the first classification. So what is linear? If dependent variable and partial derivatives occur in first degree and are not multiplied, then the partial differential equation is linear, otherwise it is non-linear. So in the first example, all derivatives occur in first degree, therefore it is linear. And in the second equation, the first term is of degree 2, therefore it is non-linear. And in the third example, both partial derivatives are multiplied, therefore it is non-linear. The next concepts are semi-linearity and quasi-linearity. Basically, semi-linearity and quasi-linearity are defined for the partial differential equations of first order. Linearity and non-linearity are the general concept. That means for all order partial differential equations. But semi-linearity and quasi-linearity concepts are for first order partial differential equations. So the definition is any equation will be semi-linear partial differential equation if it is of the form this: p function of xy multiply small p and small q are defined here. Small p is del z over del x, small q is del z over del y. So if we have the coefficient of small p, that means del z over del x as the function of xy, and del z over del y is the function of xy, and in the right hand side is the function of xyz, then it is a semi-linear partial differential equation. As an example, we can think that xy p, yes, this is the function of xy and multiply by p, then that means the coefficient of a small p is xy, and the coefficient of q is the function of xy. It should be function of xy. So here it will be, suppose it will be not z, it will be yx square is equal to right hand side function of xyz, so xz square. Yes, it is right now. So this is the example of semi-linear partial differential equation. And what is the quasi-linear partial differential equation? Quasi-linear partial differential equation we can define the coefficient of small p is function of xyz, coefficient of small q is function of xyz, and right hand side is function of xyz. So as an example, we can take this example: x square z small p, y is absent, no problem, it can be treated as the function of xyz, and yz q is equal to xy sin z. Right hand side is the function of xyz pure. Now further, in the further study now onwards, we will use these symbols. That means for partial derivative of second order with respect to x, we can use r, and for second order derivative with respect to x and y, we can use s, and for del 2z over del y square, we can use small t. So these are the basic concepts of partial differential equations and the basic idea. Hope you will understand, and also hope that you will be safe. Thank you.